Hello all, welcome to my channel. In this project, we're going to deal about AWS serverless security architecture. So let me ask you one question. So what will happen if someone sends 100 requests to your API in seconds, or like my number of requests has been sent to your API in very less time, like few seconds? Will your application survive or it's going to crash? So definitely the backend services, whether it's an API or any of the services, backend services, is going to become slow or in operation, or it's going to crash because it's not going to handle that many requests in less time, like in few seconds. So in this video, I will show you how to build a production grade secure server API using AWS. So we'll deal with real-time attack blocking, monitoring, and alerting. So in this architecture, right, let me go through this architecture here. So there are two parts actually here. If you see, right, this is the first path, and this is the second path. So this is a sunny day scenario where users can access our application. In this case, it is like API gateway, and they are going to the requester, right? Whoever requests the API, it's like a URL, right? Is going to hit the WAF here. Okay, once the request has been scrutinized, then we are going to write a lambda function. Okay, that is triggered by API. API is going to trigger lambda function. It's going to extract the IP and username, right? IP and username of the requester, and it's going to dump into the Dynamo DB. Okay, this is the sunny day scenario where usually a request has been come and we are going to extract all the information and we are going to dump into the Dynamo DB. Now, this is the second path. Okay, this is the second path where attacker or some malicious person, actor, is going to generate some thousands of requests, right? Thousands of requests, and they are going to hit our API. So what will happen? How we are going to handle it? So what will happen here is, like, as soon as, because we are setting a rate limit in the WAF, right? In the WAF. So within that span of time, like if you are receiving thousands of requests, we are going to check it through the WAF rules. So WAF rule is going to check it, and it's going to analyze the matrices, and we are going to configure a CloudWatch alarm here, right? The alarm is going to trigger an SMS topic. Okay, and then we are going to get an email notification saying that somebody has caused an attack, and we are going to get notification out of it. So this is basically the architecture what we are going to follow. We are going to follow the first part, a usual scenario, and once we are going to simulate. I'm going to write here. Okay, we are going to simulate the attack, like sending thousands or hundreds of requests. What will happen if WAF rule hits it, WAF rule hits, and then it's going to generate alarm and alarm of the CloudWatch. Okay, we're going to configure alarm in the CloudWatch, and then it's going to hit the SNS topic. SNS topic is registered with an email address, so we're going to get a email alert. So this is the basically flow we are going to follow. Now I'm going to explain each and every component here, how to build it and achieve this functionality. So let us get into the configuration part. As and when we go through all the blocks, right, we are going to understand how to configure them and how to achieve this project. So let's jump into the AWS console now. First, what we'll do, we're going to create a Dynamo DB table. Let's jump into Dynamo DB page. So here, just click on create table. You can give it any name. For example, I'm giving this login activity. and here partition key you're giving as a username, and the sort key also you'll give as a timestamp. So we'll calculate the time basically. So these are the fields. Then you can hit on create table. So it will take some time to create the table. Yeah, now the table has been created. Okay, now let's create a Lambda function. So that whenever we are going to call an API, API is going to trigger the Lambda function, and the Lambda function is going to extract the IP and username, and it's going to dump into the Dynamo DB. So let's create a Lambda function. Let's call it as a login handler, and we'll select the Python 3.11, and we are creating a function here. It's taking some time to create the function. So I was playing around creating the function and deleting it. So that's the reason it is going to throw that error, but you can accept it. So this is the basic code Lambda function gives. Now you have to adjust the timing. So here I have set it as 15 seconds timeout. And also you can adjust the role here, permissions. Go to the Lambda execution role and give it the Dynamo full access, because we need to extract the IP username and we have to insert into the Dynamo DB table. So Lambda has to get access to the Dynamo DB table. So here we'll give the permissions as Dynamo full access. Yeah, now you can just select, you can check it is a full access, and you can save it. The trust relationship is nothing but Lambda execution role. It is assuming the role is Lambda is assuming a role. Now you can go to the code and we can paste our code here. So the code I will be giving in the GitHub repository. So it's a simple code only, but we are going to extract the IP and username from the event. So the event is nothing but here it is triggered by the API gateway. You can just copy paste the code here. So let me explain the code here. This is nothing but import WAF2. We are importing the WAF2 SDK into our file. So we are importing even the datetime library. So this is the first entry point here. What we are going to do, we are going to create a variable. Okay, DynamoDB. We're calling this SDK. Okay. Next thing is we are going to enter into the Lambda function here. So the login activity is the table name. Okay, table name we are passing it to the, we are taking a variable here, we are passing it to the Dynamo DB variable here, and now we are going to extract the IP of the request. So the request IP is being extracted from here, and also we are going to pass the pass over the body, and also we are going to extract the username here. So username and IP we are extracting here, and then we are placing them in the Dynamo DB table. So we are going to put them in the table, and the return code we are sending it as 200. Okay, if everything is successful, then we are going to return it as a login is recorded. Okay, this is a simple Python code in order to extract the IP and username and put it in the Dynamo DB table. So now we are going to deploy this code, and also we need to test it. We'll send some JSON body and test the code also. You can go to the test and give some name here, and we can give the body, send some body, JSON body, and we can test it. Now you can hit on the test and see whether this code is working or not. Now you can see the code is successful and it has extracted the IP. You can also check this in the Dynamo DB table, whether the entries got ported to the table or not. It must be somewhere here. I think so. It should be in the export table items. Yes, here we can see, right, test user. It has inserted the IP and username. Okay. Okay. Now we are going to create an API gateway. We're going to create a HTTP API gateway. Let's jump into the API gateway console. Let's create an API. Here we're going to select HTTP API because it is simpler and also the configuration wise it's easier. Select on build, give it some name. Go next, and here everything you can keep it as default and create. Now the route you have to select because we are giving the route as post, so we are posting some information, right? That's the reason we give it as a login. In the path we are going to give it as a login. Now we are going to attach the Lambda function here. We can go to the integrations and select the Lambda function here. So this is our Lambda function login user. Now the Lambda function has been integrated with the API. So whenever we are going to access the URL of the API, so this is my local machine. From here I'm going to access the URL of the API gateway. So you can select this one. So we are going to curl it. We are going to send some body of the JSON format in the JSON format. So you can paste it here. The command executed perfectly, fine. Even you can check in the Dynamo DB whether the IP has been inserted or not. So for security reason, I am not able to show the IP. You can see the output of the command over here. I masked the IP here, and also you can check the Dynamo DB tables. Here also I masked the IP entry got successfully in this Dynamo DB. Now we shall proceed further creating the CloudFront distribution. So let's log into the CloudFront console. So the reason why I'm creating CloudFront is nothing but we created HTTP API and we cannot add WAF to the HTTP API. That's the reason we are creating a CloudFront distribution. Here you can select a free tier and proceed. So you can give some name of the distribution. I'm giving here API gateway. You can give the description here. Now hit on next. You can select the API gateway here and select the gateway. You can select the gateway. So path you can leave it default. Now by default this will be associated to WAF. You can just select it and the next. So you can create a distribution here. So by default it will be tied to WAF, and the rules will be will going to configure in the WAF window. So here navigate to the origins. You can see right security WAF is already configured here. Now you can copy the distribution URL. Right? You can give the distribution URL here. So you can see that I'm able to access the API gateway with the help of the CloudFront URL. So now we will configure the WAF rules. So we'll be adding the security layer on top of our API gateway. So let's configure the rule here. Let's jump into WebACL here. You can click on add rule here. This is a custom rule what we are going to design now. Now you can select here is a RAID based rule. Now you can select the action here as block because we are going to block the IP whenever it is attack has been detected. So you can give it as some name here. And the rate limit you can give it as like how many requests you want to, after how many requests you want to block the IP. So for example, he can give us like 50. So 50 after 50 requests, we are going to stop or block the IP. Like evaluation window will be like 5 minutes. So within 5 minutes, if you get more than 50 requests, then that IP is going to be get blocked. So based upon the source IP, it's going to decide whether we're going to block that IP or not. So you can hit on add rule. Now you have to make the order of the rule selection. So whatever the rule we selected, right, you have to place it in the top position because it is going to validate according to the serial number, or else first one will get executed first and later on the second one. It's like an access list. So you have to reorder the rule. Whatever we configured, we have to place it in the top. Now you can move the rule to the top order and save the order. Now we are going to simulate an attack to the API. So as I've told you, right, there are two paths. So one path is a sunny day path, what we have executed now. So the second path is attacker mode. So now we are going to attack the system with the help of a script. So we'll generate one script here. Let us paste the script here. So that script I'm going to provide in my GitHub repository. So this is going to generate like a like 1 to 100 requests to the API. So in the rule we have set is like the limit to be 50 requests, right? If more than 50 requests comes, it's going to block that IP. Now the script has executed and we can see that the additional request will generate a 403 error. So in this case, it has generated more than 100 requests. We can also check the how many requests has been blocked by going to the dashboard here in the WAF. So if you can see, right, there are like a total 104 requests and allowed are 102, and the blocked is the next two requests have been blocked. So why it is showing as 104 is nothing but, see, for example, when you are sending a JSON body, that is not considered as one request, it is considered as 2 or 3 requests because of the WAF treats in that way. So it's going to consider this like 2 3 requests. So we have set the limit as 50. So it has calculated like 2-3 requests means 100 requests. So more than 100, it's going to block the next request. That is the reason one not allowed are 1 or 2 and the rest 2 are blocked here. You can also see the region from where the request has been sent and the IP has been blocked. So you can even check this in the Dynamo DB table entries. So let's check there. So we can see, right, there are 50 entries and more than 50 entries are blocked from being dumped to the database. So far we know that our system has been attacked, but how do we configure the alerting and monitoring system? So for that we need to configure alarm in the CloudWatch matrices and then trigger an email alert with the help of SNS. So let's jump into the CloudWatch now. So I am in the CloudWatch console. Now let's configure one alarm. Navigate to alarm here. Let's create one alarm. So let's create one here. So you have to select the classic one. Next, and you have to select the metric here. So metric will be like WAF2 you can select here. And you can select the blocked. So there are two requests here, allowed and blocked. So we are creating alarm for blocked one. So you select the blocked one, and here you can select the default threshold as 0. So greater than the 0 one or next request has to be blocked. So for that it's going to trigger one alarm. So the period time limit you can set it as 1 minute. So in the step 2, you're going to select the SNS topic. Because SNS topic is not yet created, we'll create one here. So you can give it some name here. And the email address you have to configure it. And you can create a topic and you can hit on save. So you can go to next one. And here you have to select one name here. You can give any of the name. So select next and preview, and you can save the alarm now. So once you accept here, right, you're going to get a notification. You have to accept the subscription here through SMS. Once you accepted, right, subscription confirm, then you're good to go now. So now we're going to simulate an attack again. So this time we're going to change the rule again because we're going to keep the rate limit as 10 here. And just save it. And then we can execute the attack script. So I modified the attack script so that it gives the count how many times the script got executed. Now let's execute the script. So I executed the script. This is the output of the script. Now it has executed for 10 times. So the next the request, right, it's going to generate an alert here. You can see, right, it has generated the 403 error response. So the alert takes some time to generate. Now you can see, right, the alert has been generated here. So now at this time we can see also the email alert that has been generated through SNS topic. You can see, right, and now we have got the email saying that somebody attacked our system, and we can know the details from where it has been attacked and all. So we have come to an end of this project. So as an enhancement to this project, we can always integrate this one with Amazon Guardity as well as Autoblock public or block IP using Lambda functions. So if you find anything useful from this project, please subscribe to this channel. Thank you all.